Hello class, I'm Alexander Carey, and today I'll be presenting powerful trends in worldwide power generation. Introduction. I will talk to you about my data, the statistics, trends and correlations, predictions, and conclusions. About my data, I will tell you about the origin, shape, potential flaws, how I've changed it, and my purposes for this data. Origin. My data was acquired from Kaggle. It was compiled by Prajit Majender from Our World Data. The data was originally from British Petroleum and Ember. The shape of the data. The original data set had 11 columns and 6,241 rows. Each row represents a year of power generation for a country or region. Entity, which is a country or region, and code ISO 3, which is used by geological surveys as well as the intelligence community, are nominal, and the rest are continuous numerical and are at the bottom of this slide. Potential flaws. Not all countries have the same number of years worth of data. Developing countries begin around 2000, while world powers go back, like China, Russia, and the United States, go back to 1985. This data does not include personal power generation or direct use of sources for a purpose. For example, privately owned rooftop solar panels or natural gas home heating, and for the industrial example, coal as a heat source for steel foundries. How I changed the data? I removed all of the non-country members from my data. I made 3 subsets of the data. Total power generation per year worldwide, which was essentially the same as same columns and structure as the original data minus countries, and it was just the yearly totals. There's 36 of them. Power generated by each country, there's 205 of them, and there's a total list at the end, and the year was removed. Contribution of total power generated for fossil fuels, renewable, hydro, and nuclear sources by year is just the ratio of the total power that was generated by those sources, and hydro was split from renewables because hydro is stable and it's a long-term investment, because once you've built it, it's basically the only way to lose it is to grievously mismanage it, have a horrible natural disaster, or have it destroyed in a war. What I want to find out: what are the trends in the different types of power generation? Which nations produce the most power? Based off this data, when, if ever, will renewable sources be the primary source of power? Statistics. First, I will go over the descriptive statistics. Then I will detail the trends and outliers. Histogram total by year. As you can see, coal is bimodal, and that's because it's used both in high and low energy requirement situations. Electricity from gas is right skewed because it's relatively new, and didn't see wide implementation worldwide until the late 90s. Electricity from hydro is left skewed just because it's variably used, and in a lot of places where it is used, it's a lot smaller than the Hoover Dam, for example. Other renewables are left skewed just because they are also relatively new, and where they did exist, they produced relatively little power. Electricity from solar is very much right skewed, and so is renewables, because where it did exist, it existed in very limited quantities until about 2010. Electricity from oil is left skewed because it made up the majority of the world's power generation, because it was easier to perform than coal, because coal has an intermediary step where you must grind the coal into extremely fine powder called coke. The electricity from wind, same issue as solar. Electricity from nuclear is left skewed just because where it does exist, it tends to exist for a very high level of power generation. There are a few exceptions. For smaller reactors, it depends on the definition of nuclear. Descriptive statistics. The means for the traditional ones are a lot closer to their medians than the non-traditional ones. So, for example, you have coal and gas and hydro, and then you have oil, and you have nuclear, all pretty close together. Then you see wind, and wind is pretty far apart, isn't it? It's 58, that's 308, relative to its size, of course. Then solar is the same way, median of 1.9, mean of 209. That's because these technologies, it didn't really exist for the majority of the time this was recorded for. It didn't, and as we'll see soon, it didn't really hit its peak until about 2010. Yearly totals. So as you can see, coal makes up the majority of this. It's got a pretty wide thing. Its median is high. Gas is next. Median's high, pretty wide, pretty high. Hydro is pretty similar, except for narrower. Other renewables is a little bit wider than solar, but pretty narrow and pretty low. All these outlier dots here, I don't believe they're real outliers. It's just a result of solar power being relatively new enough that for the majority of this time it was just onesies-twosies. So I'll demonstrate that here in a minute with the scatter plot. Oil has a middle high generation. Wind low, pretty wide, couple of outliers, same reason for solar. Nuclear has about the same median as gas and hydro, much narrower. It saw a lot less implementation. Alright, so here is the scatter plot. As you can see, coal goes up. That's because power generation needs go up over time, because more and more places need power, because conveniences of modern life, modernization of developing countries, etc. So there's an overall positive trend in this data, and that is why. So you see gas doing the same thing, hydro doing the same thing because they're letting out more water to get more energy. And then you see solar down here curving upwards, you see wind curving upwards, and you see other renewables curving upwards also slightly, but it's a bit more stable and less, let's call it meteoric. Correlation. So there's a very strong correlation for these high producers in time. I mean, it's all above 0.6. That's a fairly strong correlation. So that's due to the fact, as I previously mentioned, that the need for power increases with time. And that's also why the first four power sources listed here all have a very strong correlation, positive correlation with each other. It's because the need for them has gone up. And you'll see some of the more negative correlations when we move on to the ratio of the power generation here in a moment. Trends and outliers. The overall trend in power generation is positive. There's no outliers in this part of the data set, as I have hopefully demonstrated. Histogram source ratio. So for the majority of the time, there was very little renewable energy in use, which is why it is heavily right skewed. Fossil fuel is bimodal because it has at times been the strongest source. It's always been the strongest source, in fact. But there was a period of time where nuclear was starting to rise up and take up some of the power generation needs from fossil fuels, and then it sort of dipped back down, which is why you sort of see that. Hydro usually makes up about 10 to 20, 15 to 20% of the thing, a bit more skewed to the right. Nuclear is bimodal just because the needs of it change. Descriptive statistics source ratio. So once again, you can see that renewables mean is pretty relatively far from its median, and that it has a much wider range than the others. So you can see that like it's very close for fossil fuels, the mean and the median. It's pretty close for hydro, and it's pretty close for nuclear. As once again demonstrated here. The portion of power for fossil fuels is the highest. It's relatively tight, and it sort of hovers between around 0.6 and 0.7. Renewables is low. These outlier dots are once again due to the fact that for the majority of time there's just so little of it, and I don't consider them to be true outliers. Hydro is about the same median as nuclear, a bit tighter, a bit higher, because nuclear just it has a bit more variability. And here's where we start to see something interesting. So as I previously mentioned, nuclear was starting to take up some of the load from fossil fuels around the time from 85 to about 2000. And then fossil fuels started taking back off as nuclear dipped. And this is because some of the older nuclear facilities were starting to show their age and were being decommissioned and not replaced. And then here, at around 2005 it starts, but around 2010 it becomes very apparent that renewables are starting to take up some of the slack, and you can see that in the downward trend here from fossil fuels as well. And at around 2018, renewables overtook nuclear power. Now here's the correlation. As you can see, as time goes on, renewable is increasing, fossil fuel is increasing, but that's due to taking up the slack from nuclear. Nuclear is decreasing strongly with time. And like I said, I would like about 20 to 30 years more previous data from this just to see what the overall trend from nuclear really looked like, but I couldn't find that. Trends and outliers. Trends in the ratio of generation. Fossil fuels saw a steady increase until 2010 and are now decreasing. Hydro is steady. Nuclear mostly steady with a slight downturn as older plants reach end of life and are shut down instead of updated around 2000. Renewables are steady, low usage until about 2005 to 2010, and then rapidly increasing around 2010. There are no true outliers in this part of the dataset either, as I believe I've demonstrated. Analysis and predictions. When will renewable sources make up more than half of all power production? Which nations produce the most power and the least? I've done a third-order polynomial regression on this, and it has a 99.75% r-squared. And here is the equation for it. I've simplified it down to 4 decimal places so that it would comfortably fit on the screen. Predictions for renewable energy. If this trend continues, renewable energy sources will make up over half the world's power generation by 2037. It's actually about 2036 some change based on my calculations, but rounding up is the way to go just because this prediction isn't that solid and doesn't have that much data to it. Top 10 power-producing nations are the United States, China, Japan, Russia, India, Germany, Canada, France, Brazil, and the United Kingdom. The bottom 10 power-producing nations are the Western Sahara, which I expect to change in the next couple of years as solar power is deployed there, Guinea-Bissau, Cook Islands, Nauru, Kiribati, Montserrat, the Falkland Islands, St. Helena, Niue, and Antarctica. And Antarctica is of course the lowest because the only power generation there is for the scientific research stations. Conclusion. Assuming the current trend continues, over half of all power generation will be from renewable sources by 2037. Power generation is increasing over time due to the increased usage of electronics and the developing nations beginning to have widespread access to electricity. Here are my references.